that we are again able to get the red black tree. Now in the last class we started up with the various operations that can be do in the red black tree. They are search operation, then it is the insertion as well as the deletion. So why we are retaining these properties, and why do we have to apply the fix up? The main goal behind that is so that we are able to get all these, we are able to perform all these operations in the log n time. So in order to retain that whole log n time, we are going to balance the trees, and so that the height of the tree is always of the order of log n. So in that case, if the height of the tree will be retained of the order of log n, we will be able to perform all the operations in the order of log n. So this is the main idea, main goal behind taking up all the steps of fixation, that we say that whenever some property, whenever when a single property is violated, we apply the fix up operation according to the property that is violated. So now based on the various properties, whenever we are doing the insertion, we have different strategies which are adopted in order to fix up. That means in order to get back study about these your insertion operation and the various cases that we come across. Whenever, see, the first property here, you can see this property is that the root is black. So the every node is either red or black. That is absolutely fine. But I'll just wait. So on the top right corner, you see I have written the red black property so that you can revise. So the root is black. So and one there is another rule that says the new node that is inserted, that is always a red node. So in that case, the first node that will be inserted, that will also be a red node. But the red black tree property says that root is black. That means we have to fix up from the very first step. So how to fix the violation? We have to color it. Then this another you can say the next property, let's say we have, if a node is red, then both its children are black. So whenever we are inserting a node, we have to check this particular property also. So now we are going to discuss the various cases that arise and how to fix the violations that occur in all these cases. So I'll be giving you certain tips for various problems so that it becomes easier for you to understand that which particular rotation and operation, and at for what node you will be applying the rotation, right? So how to apply the rotation, and then you can say whether the rotation should be applied on the parent node or on the grandparent node, then under what circumstances we will be doing a particular type of rotation, and then which rotation we should perform, whether it should be the right rotation or it should be the left rotation. So I'm going to give you certain tips for that, that will make it easy for you to understand and do any kind of problems related to red black tree. So just focus. So first thing is like insert Z. Insert Z means we are going to represent every node, new node, as a Z node, right? And the first node that we insert, we know that every node that we insert, that has to be a red node. So insert Z and color it red. After that, what do? Recolor and rotate nodes to fix the violation. So now, based on the strategies, right? Whenever we are discussing about the insertion operations. Whenever we are inserting, we can come across any of these four cases. So we will not face any other cases at all, you can say. So whatever case comes across in after the insertion, that will lie in any of the four scenarios, you can see. Z is a root, the first case. Now, see, I told you in the last class also, in red black trees, uncle plays a very important role. Here, uncle is very important. So all the fixations that we will be performing, that they will depend upon the color of the uncle node. So if the Z dot uncle is equal to red, then what we should do? If Z dot uncle is equal to black and it forms a triangle, I will show you why I'm calling it a triangle, just to make it easier for you to understand the situation and then take appropriate action or the violation fix up. Then Z dot uncle is equal to black, but it forms a line. So what does it mean? Again, I'll be showing you with the help of examples what is called as a triangle over here and what is called as a line over here. So case 0, Z is equal to root, right? So the first node we have inserted. So like whenever we are given certain keys in order to create a binary search tree, and then we have to do the, you can say, or to create a red black tree. So the first node is always a red node. Now what do we do? The solution is color it black. That's it. So this is the solution for the first case, case 0 we call it. If z is equal to root, then color it black, and we are able to fix up the violation that was there for the red black tree. So now it becomes a, so you can say even if it is a single node, it is a red black tree, right? So next move on to second case, that is case 1. So z dot uncle is equal to red. So what do we do? Let's say, see a scenario. So here you can see, sorry. So here you can see the left hand side the tree. B is the parent node, A and C, and Z, they are the child nodes. Z is a new node that we have inserted, and that has become the right child of A. Now what do we do? Again, I told you in the last class also that here first we have to see what is the color of the uncle. If the color of the uncle is red, only thing that we have to do is recolor. There is no rotation required at all. So after recoloring, see, we recolor the node A and node C to the black and node B to the red. So after the recoloring of this particular subtree, here you just remember this is just a subtree. So we are just focusing on the part where we are inserting the node. But these violations, they climb up as in the complete tree towards the root. So now there is a possibility now after recoloring also the upper part of the tree becomes you can say there is some violation of the property in the upper part of the tree. So here you can imagine that for the, so if there is a violation, so as we start fixing up the violation, then your z moves upwards. So if it would have been the part of the complete tree, the b would have become the z node if it would have been violating any of the properties of the red black tree. So for the time being, just remember this thing, that if z's uncle is equal to red, that means it is a red node. That you can see who is the uncle. So the parent is A and the parent sibling is uncle. So the C node is uncle node and it is red in color. So what we do? So the only operation that we have to apply is recolor it. So we recolor A and C as black nodes, and we recolor the B node as a red node. So now after, see, we'll be doing the complete examples, and then we will see how the violations are, going up the tree. So first you have to remember the various strategies that we have to adopt. So understanding the cases, what can happen. So we have seen the root case, we have seen when the uncle is red. Now we have two cases where the uncle is black. So when the uncle is black, in that case, again, we have two cases, that whether it is forming a triangle or it is forming a line. So let us see what I'm calling as a triangle. See over here, Z is a red node, as we have done. Z's uncle is C node, which is black in color. And here you see, can you see some triangle over here? If we see the B to A to Z, it is some kind of triangle I am calling it over here. If this kind of scenario is there, that means B is A is a right child of B, and Z is a left child of A. So there may be the opposite case also, like here you can see. So now in the first part, you see A is the right child of B and Z is the left child of A. Similarly, there is a you can see. So I'm just telling you this may be formed in any of the subtrees. So you just have to see whenever we are talking about the new node that is being inserted. From there, you have to see the angle, or you can see the triangle between the child node, parent, and the grandparent node. So only these three nodes you have to see if they are forming a triangle, something like this. Some V, you can say V is being formed. So whenever we come across such kind of situation, you have to rotate the parent of Z. Now, if we come across such kind of situation where some V or some triangle is being formed, so in that case, in order to fix up the violation that is being happened, so we have to rotate the parent of Z. Now the question is in what direction we should rotate the parent of Z. So just remember whatever kind of rotations you are doing, you have to do the rotation in the opposite direction of the Z. So if the Z is in the right, if Z is a right child, you rotate the parent on the left hand side. If the Z is a left child, you rotate the parent on the right hand side. So see the direction of the Z and rotate the parent on the opposite side of the child. So when we apply this rotation on our tree, so this was the original one that we were focusing on. We can take the other one also. That is quite easy. So now what we will do? It is forming a V from B to A to Z. So what we will, and the the uncle of Z is a black node and it is forming a triangle. So what we will do? We have to rotate the parent of Z. Parent of Z is A node. So when we rotate the parent of Z, so the direction in which we have to rotate is, it is opposite the direction of the Z. Z is in the left, Z is the left child of A, so we will rotate the parent to the right side. So can anybody tell me, if I rotate the parent to the parent A to the right hand side, how it will look like? Yes, please. Soumya? Soumya Gupta? Soumya, are you there? Aditri?
Yes, ma'am.
हाँ बच्चे, अगर हम ए को राइट हैंड साइड में रोटेट करेंगे तो क्या क्या फ्लो बनेगा, ट्री कैसा दिखेगा?
मैम ए के लेफ्ट में बी और बी के राइट में सी और ए के राइट में जेड.
बेटा ए को हम राइट हैंड साइड में रोटेट कर रहे हैं. वी आर रोटेटिंग ए इन द राइट डायरेक्शन.
हम ए को राइट में.
See, when we, okay, just it's okay. So when we rotate A, if you remember, see, if you will not remember the rotations, the left and right side rotations that we learned in the very first lecture in the very beginning, what happens when we rotate to the left or we rotate to the right? So when we are rotating A in the right side, Z will become the parent of A. Here you see. Z will become the parent of A and Z will become the child of B. So this is how the rotation has happened that we do. This is the right rotation of A because Z is hand side. So now it becomes a new case. Still, here you can see the parent node is a red node. So still we are facing the violation. Now, if we have such kind of scenario, right? So such kind of scenarios, we say the Z's uncle is a black node, but it is forming a line. Here you can see like this. This is a line. This is a line. So here you can say now it has become from the triangle. You can say we can come across this. So you can say in such kind of scenarios because of some previous fix up or it may be in the new insertion also. We can't say because we are inserting the node in the like the binary search tree node. All the keys on the left hand side, they have to be smaller than the parent node, and all the keys inside, they have to be bigger than the parent node. So now it has become a new case that I'm calling it as a line. See, if we come across such kind of problem, right, such kind of cases, the solution is to rotate the Z dot grandparent. Here it is. Here you see. So now who is the grandparent of Z? Grandparent of Z is B node. Again, in what direction? Opposite to the direction of Z. Z is the right child of A. So the grandparent will be rotated on the left hand side. Anyone tell me that in what will be how the new subtree will look like? Can anybody tell me? When we will rotate the B will become which node will become the parent? B will be going to the left. Which node will become the parent?
A will become A.
A will become the parent. So remember, in all the rotations we are going through, the child becomes the parent and the parent becomes child in the rotation. So the A will become the parent node and B will become the left child of A, right? And D will become the B will become the left child of A and D will become the right child of B, like this. And if you will go back to the slides in the very beginning, we learned two rotations which are symmetric. One is left rotation and one is right rotation. So you learn those rotations. When we are making a left rotation, in that case, the left child of the other node becomes the right child of the opposite node. After, see, that means whenever we come across z dot uncle is equal to black line case, we have to do two things. We have to do rotation of the grandparent and then we need to recolor it. So here you see, after the rotation of the grandparent, we come across the first tree where A becomes the parent node, B becomes the child node, and the D node, here you let's go back and see. D was the left child of A, now it has become the right child of B, right? And Z is the right child of A. Now we have done the rotation, now we have to recolor it. Recolor which nodes? Recolor B and Z. Sorry, the Z is already red. So we recolor the B, which becomes red, and then we recolor the parent node, which was red. Now it becomes a black node. So after applying the rotation on the grandparent and then recoloring it, we are able to fix up the violations with red black tree. Now you can see that the final tree we are getting over here, this is a red black tree. So it may be a tree, but this subtree is a red black tree now. And after that, again, see, wherever the violation has reached up in the tree, that node will become Z node, and then we will keep on fixing up these violations up the tree till the tree becomes a complete red black tree. So these are the four cases that which arrive in any kind of, you can say, you will come across in any kind of red black tree. So what are these four scenarios? If Z is equal to root, then the solution is just color black, right? If the Z dot uncle is equal to red, just recolor it. Okay, you don't need to do, when the uncle is red in color, you don't need to do any kind of rotations. You need to apply the rotations only when the uncle is black. So, and in that case also, if the uncle is black and it is forming a triangle between the new node that is inserted, that is between Z's parent as well as the grandparent, we will see what kind of angle they are forming. If they are forming a triangle, in that case you have to rotate the Z dot parent and in the direction opposite to the direction of Z. If Z dot uncle is black and they are forming a line, then we are going to rotate the grandparent. And again, the rotation will be in the direction opposite to the direction of the Z, and then we have to recolor it. So in that case, so you can say when we have a uncle black and they are forming line, we have two operations that to be performed. So two fix-ups. So one is rotation and another is recolor. But in case of triangle, we have to just rotate the parent. And when the uncle is red, so no rotations, only recolor. Similarly, in case of root node, we just have to recolor because it is the only root that is there. So no other actions required. So if any of these four scenarios or any of the actions that we have taken that is not clear, you can tell me. Otherwise, we move on to the problems. Yes, please. Anyone who is, because next week your exams are starting, so you start going through it. So in your tutorial classes, I'll be completely taking up your doubts. So whatever doubts you have, you can discuss your doubts in the class as well as in the your lectures also. Okay. So any doubts? Any doubts in the various scenarios that we have discussed?
No, ma'am.
Okay. Okay. So now we again come up with that insert fix up coding part, that the function that we have created. You can see while z dot parent dot color is equal to red. So that means till the parent color is equal to red, this will move on, right? Now let's come across the first case. So you can see I have written it over here, the case one. If y dot color is equal to red, that means if the parent uncle is red. So what do? We just have to apply the colors. Changing in colors we are doing. Z dot parent color is black, y dot color is equal to black, and z dot parent color is equal to red. That means the grandparent, right? And z is equal to z dot parent. That means now z is updated, because the since we have just learned that a part of the subtree is now balanced, but if there is a possibility that the upper part of the tree is now unbalanced. So the z is you can say z has climbed up, and the grandparent node, it becomes a new z node. Then if z is equal to z dot parent right, so that is your second case where we are saying that you can say it is forming a triangle. Then what do? We assign the z is equal to z parent, and that becomes a new z node, and we apply the left rotation, because z is equal to z dot parent right, because that parent is in the right direction. The rotation will be performed in the left direction. So similarly over here in the second case, z dot parent dot color is equal to black. That we just made the parent black, and z dot parent color is equal to red. So made the grandparent red. So then we do the rotation. Here you can say, so this was case 3 where it is forming a line. So here the recoloring is created first, and then the rotation is applied after that. So here the two operations are being performed. That is, one is the grandparents rotation, and here you can see in the right rotation we are passing t, and then along with that what we are passing, the node that has been passed is z dot parent, and in the previous we are just passing the z, right? So with the rotation will be applied on the grandparent in the case 3 where the line is formed, and in the case 2 where the triangle is formed, only the parent rotation is being applied. And here you can see the one thing that is there, the t dot root dot color. The first case number 0, where we are inserting the node, and after the insertion what do? It may be a root node. In that case we are just coloring it black. So all these 4 scenarios are being covered in this insert fix up function. Okay, so now who will tell me what is this case? Which case? Case 0, 1, 2, 3. And what is the solution for this? New node that we have inserted. Huh?
This is case 3 line वाला.
Line वाला case. So अब इसमें किसको rotate करेंगे? तो
grandparent.
हाँ, तो final क्या बनेगा फिर हमारा tree क्या बनेगा? Which will be the parent node and which will be the child node?
5 will be parent, 15 will be child.
Right. So the so here the case 3, that is z dot uncle is equal to black. See, if nothing is visible, just remember, if nothing is there, if there is no right or left child, in that case we have to assume it is a sentinel node that is always black in color. So the sibling of 5 is a sentinel node, that is nil node, right? And it is always black in color. So z is the node, z is the new node that we have inserted. 5 is the parent node, and the sibling of the parent node is nil node. So in that case we can't say there is nothing. There is always, see, there is always a leaf node that we call it as a sentinel node, and you can see over here it plays a very important role. And since it is coming under the case 3, we will be doing our we will be rotating the grandparent. Now in what direction we will be rotating the grandparent? In the direction opposite to z. C is a left child, so we will rotate the grandparent to the right side. So when we rotate the grandparent to the right hand side, so after rotation, see, after rotation here I've written it clearly. After the rotation, this is the first tree that looks like. So here you can say, because the colors were there. Now again, still the coloring property is violated, that says that the red node can have only black children. But here the red node is having one red children. What do we have to do? So we just have to recolor it. After recoloring, so it becomes the final subtree, that is a balanced binary search tree, and it is following the all the red black properties. Clear? So it was just a subtree. Now let us move on to the complete tree. So in the complete tree, we will see how these properties are, you can say how these violations are climbing up the tree. Now, our new node is a Z node, that is the new node that the key value is 10. So where it will be inserted?
Recolor करेंगे.
Yes.
और
This is case 1. Case 0 हमने root को माना है क्योंकि uncle red है, तो what we will do? We will recolor it. Very good. So let's recolor it. So this was the case 1. Z dot uncle is equal to red, and the solution is to recolor it. Now when we recolor it, so what do we have to do? We color the node 9 to black, color node 13 to black, and we color node 12 to red. Right? So now this part of the subtree, here you can see this part of the subtree is now balanced, and it is a red black tree. But what has happened in balancing this part of the subtree? Now the 12 node, the node number 12, if you see, because the violation of the new node, that is the old node, has just climbed up. So by climbing up that Z, so now the new node, that is the 12 node, it becomes a new Z node. So this was what I was telling you when we were learning about the various case scenarios, that that time we were focusing on only the subtrees. But while balancing the subtrees, any of the subtrees, the violations may have moved up. So we move from bottom to top, and finally we are able to balance the complete tree. So now who will tell me? Who will tell me now what is this case scenario? Kyunki 8, 15 or 12, they are making some kind of triangle. ये जो tips मैंने बताई हैं, so that things become simpler for you. Okay. So 8, 15 and 12, that is forming some kind of triangle, and 12 is a which node of 15? Left node. So grandparent will be rotated in which direction? Yes?
Right direction.
Right direction, in the opposite direction of Z. Right? तो अब इसमें नया tree क्या बनेगा? Which node will become the parent node? Who will tell me? Which will be the new parent node? Grandparent.
Ma'am, 15.
Yes. 15 will become the new parent node. Okay. So this is a little more complex. So I'll show you the solution. So this is the new Z node, because now this part of the subtree has become unbalanced, because it is violating the property that a red node cannot have the any other color children. Red node can only have the black children, right? So it is forming a V-like structure, or you can say the triangle. So what do we do? So we do, sorry, it is not we are not going to rotate the grandparent, because it is, sorry, it is forming a V, it is not forming a line. So we are not going to rotate the grandparents. We are going to rotate the parent only, and the parent will be rotated in the opposite direction of Z, right? Z is in the left, so it will be rotated right. So this is how it will be rotated. Now, after that rotation, any doubts in this rotation? Yes? So here we have seen this particular case of triangle, and we are going to rotate the Z dot parent. Z is a 12 node, its parent is 15, and 15 will be rotated in the opposite direction of the Z, that is in the right hand side. So when we rotate in the right hand direction, the child node 12, it becomes the parent of 15, and the right child of 12, it becomes the left child of 15 node. And now the new node, again the same property of parent node, being red and the child being also red is violated. So the 15 node, it becomes a new Z node. And now see this, now this is the case 3. That is, it is forming a line. Since it is forming a line between the Z node, its parent as its grandparent, we are going to rotate the grandparent. And the grandparent will be rotated in the right direction, sorry, in the left hand side, because 15 is the right child of 12. So after making this rotation, so you can see, because after every rotation we do, the parent becomes child and the child becomes parent, right? So now the 12 node, it will become the parent node of 8. After this particular rotation, so after the rotation, you see the tree looks like the left side. And now what we have to do in the case 3, we have to apply both the rotation as well as the recolor. Right? So after the rotation and the recolor, we are finally, so what we are recoloring, we have recolored 8 node, it was black to it, we have made it red, and the 12 node, because it has become the root node, and root node can't be red and it is violating the property, so we color it black in color. And finally we are able to, you can say, retain, fix up all the violations, and we are able to get a balanced binary search tree. And the goal behind doing all these efforts is that we can have a guarantee that whenever we are using the red black tree, we are able to you can say perform all the operations in O log n time, and that we are able to do rotations. We are also able to retain the height of the tree of the order of log n. So this is the main goal behind doing all these efforts of rotations and recoloring. So red black trees are very important and data structures. They are used in the various kinds of applications, like in the Java collection API, your tree set, hash maps. There you can say all these data structures, hash map and all these data structures in the collection API of Java, you can say they are built on top of the red black trees only. And you can say for the geometric search, range search, queries, k-means clustering, there also these red black trees are being widely used. Then you can say in the Linux also your the red black trees are being used, underlying the underlying data structures in the Linux for certain operations. You can say for certain the Linux applications, you can say they are built on top of the red black trees. So the analysis of insertion, as I said, the insertion of the new node will be performed in O log n time as the height of the red black tree is O log n, because every time we are making certain rotations, we are trying to retain the height of the red black tree to be of the order of log n. So when we are fixing the operations, every rotation we do or we recolor, it just takes O1 time, right? So it is a constant time that takes in order to perform that particular operation. So the case 1 is shifting Z 2 levels up. So even if it reaches the root, it will do that in the O log n time. So therefore, all the operations that we are performing, whether it is rotation or recolor, it is just taking the constant time. So, and all the, you can say the for loop that will be executed, in the maximum O log n. N. So the total time that will be taken for completing the complete process of insertion is still O log n. So that means your red black trees, they are basically provide the guarantee of doing or performing all the operations in the O log of n time, and which is happening because of these rotation operations as well as the your recurring operations. Now this is an exercise for you to do. All of you note it down. You have to do it using your hands, and then you have to upload it as a class assignment. This is mandatory for you to do. Is it clear? You can note down. So you have to create a red black tree, and at every stage you have to write which property is being violated and what actions you are going to take in order to fix up that particular violation. And you have to submit it by tomorrow. So that's all for today.
मैम सबमिट कहाँ पे करना है ये?
बेटा मैं जहाँ पे ट्यूटोरियल्स आते हैं वहीं पर आपके लिए मैं एक असाइनमेंट क्रिएट कर रही हूँ, वो करनी है आपको।
ओके मैम।